Ready?
Yes. All right, so welcome everyone to the StatPREP webinar sponsored by the MAA on what's normal. So it's going to be on what's normal. The presenters are there, and of course the date is February 22nd, 2019. A couple of things to just let you know. MAA is going to be recording this, and this is their policy on doing that. And so I want to make sure you knew that. So you're just agreeing to being part of the recording. I posted on the StatPREP website under webinars, so you can watch them in the future. Whoops, I missed a couple things. Sorry about that. So there's some guidelines to this. If you have any questions, feel free to ask them. Somebody will be monitoring the chat room and will be letting us know if there's questions that come up to the chat, and we will be answering them when they're asked. And then at the end, there's a survey that we'd really appreciate if you would take to help us with these webinar programs. So my name is Kate Kozak. I'm one of the presenters. I'm from Coconino Community College in Flagstaff, Arizona. I don't know if you've heard of Flagstaff, Arizona, but we just beat our record of like 35 inches of snow in a 24-hour period. So that was from 1915. So we're on a great day of snow today. But that's where I am. So Danny?
I'm Danny Kaplan. I teach at McAllister College, and I develop a lot of the computer materials for StatPREP. My role today is mostly going to be to moderate the chat room and try to answer questions that might have to do with the software or the documents that you're looking at.
And I'm Laura Antiscornia. I represent the MAA. I help with the programming, and if you have any questions, I will be moderating in the chat, or if you have any questions post-webinar, please feel free to reach out. Thanks.
And then if you could please introduce yourselves in the chat window and let us know who's here, what your name is, and what college you're from, that'd be wonderful. So we'll give a couple minutes to let that happen. So has anybody posted who they are and what they're from?
Okay, yeah, I'm seeing them come in on the chat.
Okay, I can't see the chat.
Yeah, we've got Haishen Yao and Susanna Mar. Okay, so so those are the people who are outgoing or who have found the chat box.
Yeah, if you haven't found the chat box, if you go into the bottom down here, there's a place to do chatting. There's a question and answer. I don't seem to have the chat up on mine at the moment.
In your browser, not in Zoom.
Yeah, that's right. In my browser. So, all right. So let's go on and talk about the webinar. Oh, there's more.
Thanks, William. All right. Well, that's 3. So let's start with that.
All right. So welcome everyone. So just a quick outline of what we're going to talk about. We're going to give you a quick overview of the StatPREP website if you haven't looked at it lately. We will be looking at a class lesson called What's Normal, and then we're going to be going into some background information of why we're using this and some assessing information, and then we'll have some room for questions. But please ask questions throughout. So the first thing I'd like to do is take you to the StatPREP website. Laura, and if you could put this website in the chat room, and then people can go to it also. And so I want to click on that and take you into the chat room. I'm sorry, not the chat room, into the StatPREP website. This is when you get into the StatPREP website, this is what you'll see. Right now, there's information about the webinar that we're doing right now. But there's past information from other postings that have been done on here. You're more than welcome to look at those. We have the workshops. So we do offer workshops. This summer we have several, and you can see that we're having one in Hartford, Connecticut, Seattle, Fort Worth, Texas, and Washington, D.C. area. So you click on these, you can find out more information on where the dates are and so forth. Again, we have the webinar series. So you'll see, if you go into here, you'll see we actually have information about our webinars and then past webinars we've had. If you click on them, they'll take you to our YouTube channel where they'll give you information about those. If you'd like to apply to the workshop, you can click on this apply for a workshop and fill out, it's not a very long application. And then there's also newsletters that we put out. So if you want to read about the newsletters, click on those. You can see the different newsletters we've put out so far. And then here's the about has more information about what StatPREP itself, kind of how it got oriented, how we started it, who we are, and then our connections with the MAA, AMATIC, and ASA. So we're going to actually go into the resources. Under the resources, there's little apps. These are activities you can show your classes and work with your classes. There's no R involved in those. It's pretty much just a web-based activities. There are previous webinars on some of those. There are tutorials that will help you teach you about some of the topics, so you can also use those in your classes. There's some data set suggestions, places where you can get some data. And there's information on our workshop and hub leaders, so you can get information on that. We're going to go into class lessons. And in class lessons, we're going to look at, this gives you an idea of what they are. There are a bunch of different lessons. We have the first day lesson, which there's been a webinar on that one. There's some other collecting data ones. There's been webinars on this one. And so forth, the different webinars you can go to. We're going to go down to this one that's called What's Normal. So if I click on, I can either click on the picture itself or click on the URL here, and it'll bring this up. And this is the What's Normal class lesson. And I actually do bring this straight into my classes and work with this in my course. And my students actually also have access to this. I just copy the URL and post it in my Canvas site, and they can then go into it and see kind of what information they're going to be, can actually work with this as we go. And that's kind of useful. We have computers in my classroom, but if you don't have computers, this can also be done on any browser, so on any device. So you can use a tablet or your phone and read through this. And so I actually give this to my students, have them read this. We're going to talk about what does normal mean. And this is one of our important things we do in schools is we talk about this normal distribution, but we need to remind them that normal isn't what they think. It's not normal behavior. It's normal in another reason we call it that. So I like to go into this topic. And then this, if we go to the next page, this is content, pregnancy and birth. It actually is data on the pregnancy and birth of basically what age mothers were when they had their babies, and what their age was. And then we can look at what's the oldest age the mother would have a baby and what's the youngest age based on the data from the CDC. And it's kind of nice to be able to actually use data for the students to actually work with, and not just working with static, this is a normal distributed data. It gives them an idea of how to work with the data and see what happens. I prefer that because I think the students understand a little bit better about data with this information. And again, I have them read through this. We talk a little bit about some of these topics in class. We then say, you know, let's kind of think about what would it be for mothers younger than what is usually considered to have a baby, and what age do you think a mother's older to be and considered to be unusually old. And so we might use this. Where I live in northern Arizona, we have a lot of teenage pregnancies that do happen, but there's not necessarily a stigma about it. So unusually young is kind of, it just would be we have youngness happening to that. but it doesn't mean that we consider it, we don't give it a, we're not trying to make any kind of judgment statement about it. So I talk about this with my class and have them go through it. And then I actually can show them the data. And this is actually the data from the CDC. So this is actually from 2014, the mother's ages at birth for all the babies born in the United States. And so this is actually a dot plot. You can't really see the dots because there's so much data here, but you're not really looking at anything else, but you can talk to your students about what kind of distribution does it look like. And then we have young, old, and typical on here, but that's just based on just kind of what it's set at. And then I have my students kind of talk about what would they think it is to be young or old having a baby. So like you can move these sliders around and you notice that on the graph, the young grew bigger. And so you can actually see and say, well, I think 9 years old or less is way too young to be having babies. And then we can talk about what we think is kind of what we would consider a young woman having a baby. And so that all depends on where you're from. Because like I said, every state has different ideas. Every community has different ideas. And so I ask my students, I poll my students and I say, so what do you think would be a woman who's young having a baby? And so usually I get in my area around 21 is considered young. But like I said, they could be almost anything. And then you can see, hey, this means this 13.9% of the babies were born in this young grouping, to women that are considered young. And then you can do the same slider thing with old. You can pretty much say, you know, anybody who's probably, oh, I don't know, 62 is definitely way too old to have a baby in most women. And then you might move up where you think older women are. So you might say and pick maybe 42. Or I actually, again, ask my students, and usually I get somewhere around 40 as being the value. And then you can see, well, that's only 3%. So you can talk about that information, have these sliders move around, and then you can pull your class. Plus, they can be doing the same thing of what they consider to be in their groups or on their computers. And then it actually gives you the percentages. Beyond young, there's 0% that are what you consider beyond young. And then beyond old, there's 0%. So we kind of got those right. And then we can see our other percentages, and we can see that what we consider neither old nor young, typical, is about 83.1%. So that's about 83.1% of the data is in there. And it just gets the students to kind of see what's happening with our data. And so then if you move to the next page, that data actually, that kind of talk was actually put on here, what we considered it. And then we can actually talk about the normal distribution. So this is our data, the gray and kind of pinkish is our data. And then above there, this red curve is the normal distribution. So this is based on what the actual normal distribution is. You can actually turn it off if you don't want it there and see just your data. You can bring it back. You can turn that one off. And you can see that the CDC data does in fact fit the normal distribution pretty well. And which is kind of nice to think about. And then we can talk about the standard deviation or the standard error of the data and what is actually happening. And then you get to kind of introduce the idea of what the empirical rule says. That what you considered kind of young, we thought it was about 13.6%. We're kind of getting in there about 13.9, so we weren't too far. Our too old was a little big, 3% is what we thought, but it should have been closer to 13.9% if you went all the way to the standard deviation. And so you can kind of get that idea, play around with that. And then here's the questions that kind of ask, and this is why I like this, because my students can actually play around with this a little bit and kind of think about what they have and actually answer these and tell me if they're right. So it looks like we're almost a match, or there's a normal mode overstating the fractions, or the normal model understates the fraction of it. Kind of the normal model overstates the fractions by about 30% or about 40%. And I think we're almost exact match. So I'm going to go with that one. And I can submit my answer. And actually, it says incorrect. So I can actually think about changing my answer. I can try again. And maybe this time say, we're about 10%. So it gives you a chance to kind of see how well did you guess your model based on the model that actually is the real data.
Well, I think that question in particular is comparing just for 25 to 31 years.
That's true. That is true. I'm sorry. You're right. So that's just looking at what this was doing. And it looked like we were pretty close, but not perfectly close. The other one, the 33 to 55 years, that's this area here. We actually didn't estimate that one well at all. So we could actually say that our model underestimates this fraction probably by about 20%. Oh, still wrong.
No, so it's not our model of what's unusually old. The model here is the normal distribution.
Oh, that's right.
And you can see for mothers 30, 35 or so and older, it's right on top on the actual distribution.
That's true. And so this is something you could talk to your students about, is when you kind of mess up what the questions are, you can kind of see what is happening and kind of talk about what that data is doing. And then there's more questions you can actually have. So at what age does the actual distribution density of mothers exceed the normal distribution model? So looking up here, we can see this is again the real ages, and it's much higher here till about 25 it looks like. And then on this end, it looks like it's about right on. So it looks like our real ones are kind of over from about, I don't know, about 25 and below. So let's see. So I'd say around 20, because we don't have 25 in here, but maybe around 20. And we got that one right. So this is actually a good formative assessment that you can do with your students, is seeing how close were they, figuring out how well their model matched the actual, their data matched the model. And then we can talk a little bit more about the normal versus normal, kind of what is happening here and what's going on with this, and looking at what's going on. And you can talk about that plus or minus 2 standard deviations and what's happening with that. And you can give that kind of idea, and they kind of get that concept of the plus or minus 2, looking at this graph and seeing what's happening. And then, like I said, you go read through everything and see kind of what it is and see how well you are meeting it. And then there's some more questions here that we can talk about and see kind of where are the red marks in the plus or minus 3. So here's what is the real mark for plus or minus 2 standard deviations. Right, Danny? It's this one here, right?
Yeah.
Yeah. And then seeing how close does our data match it. And it doesn't look like what we considered too old or too young actually matched up real well with those lines. So we might need to rethink about this one for sure. And definitely this one, we might be able to bring that mother's age down a little bit from our 40. Plus or minus 3 looks like we're almost right on. Well, not here, but over here it looks like we're about right on. Some of it's typical, and you can kind of talk about what's happening. Hey, look, the data is getting really small down here when we're not typical in this 2.3%, and this data is also getting much lower down here. So you can kind of get that idea of what's happening. And that's kind of what I work with doing these. Okay. Have there been any questions yet?
Not yet on the chat panel.
Not yet.
And you can actually go back to any of these pages. And so if you want to, you can go back and adjust what you consider too old and too young and see if you get a better values with those and see if it matches up a little bit better. And then go on to and see how that adjusted and see how that changed. And you can keep going and see kind of how does that match up with this plus or minus 2 and kind of play around with that some more. So it gives you an idea of thinking about what you think is young and what turns out is really based on the normal distribution considered young. And we can have this discussion in class. So it gives a chance to also bring in data into, not data, but data into your class to talk about a little bit more about what it means And that's what I like about this one, is it really gives the students a good understanding of the normal distribution and what's happening with it and how it actually is used to model data. And one of the things that I like about this also is that it reminds students that this normal distribution is just what statisticians have determined is what we find to be typical. It's not really what matches all the data perfectly. It does a pretty good job for a lot of the data, but it's not perfect. So just reminding your students that it's a model that fits the data and not that it's like the answer to everything. So I'd like to go back into here. So we were going over that lesson. So again, what I want to talk about is that it's about modeling with the normal curve and what is actually happening with that and what data kind of fits with that. It gives them a context of seeing that it's not just we're seeing this out there in the world. We use the normal curve because we do see this happening a lot in nature, but it also gives the students a way of checking out and seeing what's happening and seeing that experiment. And reminding them again that it's just a theoretical model that we're using, that is not necessarily always being, it won't match everything, but it does a pretty good job for certain data. And then letting them know it's just a model and that's all it really is. Looking at the data and how it is distributed is important. So it gives them a chance to also see that the distributions come from where the data fits and not the other way around. It's not that we created these distributions and think, oh, theoretically, this is just what's happening. We actually can see what's actually happening with the data. And then understanding the distributions is very important because we actually see these lots of different places and not just in this theoretical models, and understanding what they are. If you get more into the concepts of bootstrapping and randomization, then the distributions become very important and they're not necessarily normal distributions that we're working with. And it gives the students kind of another way to understand what distributions are about. I don't think students really get a good understanding of what they are until later. And then this gives them a chance to actually look into it some more. So my students actually have liked this and gone into it. I want to take a few minutes to just talk about how we assess it. So a formative assessment is kind of, we were talking about that a little bit, is that students would work through the class lesson, answer those multiple choice questions. You could then ask your students how many of them got them correct. And then if a large part of them didn't, like Danny actually did, we can actually talk about what happens with it. Why didn't they get them correct? What is the concepts and what is actually happening with these graphs? So it's a good way to kind of work with that and get my students to figure out what's going on. And then the questions at the end, I kind of didn't spend a lot of time on them, but there's questions you can actually class at the end to see how they answer those questions. And so it's not just a yes, no, did they get it right, but how did they actually answer those questions? What kind of information did they give from those questions? Did they give, did they really have a strong understanding of what the normal curve is doing and what the empirical rule is talking about? I like to remind my students that I don't really like the empirical rule because we do have the way of calculating with the normal distribution, but it is there and it is a useful thing to have. A lot of them will see the empirical rule when they get out there in the world, when they go and take their kids to the doctors and they take their kids to anything else they do. They're going to see that empirical rule probably thrown at them and talked about. And so it's kind of a useful thing for them to see. And then, and so asking those questions at the end gives them a chance to kind of answer them and see what's going on and seeing if they understand the information. And it gives you just a way of realizing, do I need to go over this some more? I also, once I do this introduction, I then do go on to show them how to do calculations with the normal distribution. I actually use R in my class, so we actually do those calculations on by hand, not by hand, but we do the calculations with R. And we can then talk about, you know, what do these probabilities tell us and what do they mean? Some summative assessments we can do if you would like to, is because I actually do go over how to do these things, I can actually give a test on the normal curve as I always have. This What's Normal class lesson is really to introduce the concept of a normal distribution. It's not to take over from doing any of the other calculations we actually do with the normal distributions in our classes. It gives them a good chance to kind of talk about it, but you still can do the other calculations and do the other discussions, and you can give a test like you normally do, because this is just an introduction. And then you could also give your students a data set that follows a normal distribution and ask them, what proportions does it follow? How does it compare to the normal distribution? So you can actually go through and do the same things we just did with this normal one with another distribution. I guess we're a little quick today because this isn't a very long one. So I wanted to find out if you had any questions. Also, if you have any questions, you can also ask me or Danny throughout the year or throughout any time, asking us questions that you have on how to use this material or what to do with it. Again, there are many other lessons that can be used in classes. There's many other little apps that can be used in classes that will help the students. So are there any questions out there?
So are people going to unmute themselves, or they're going to use the chat window to ask a question?
I can unmute everyone, or you're more than welcome to put a question in the chat box.
Why don't you unmute everyone, and we'll see if this system doesn't get overwhelmed with sound.
Okay. All right.
So Kate, I'm going to ask you a question just while people are getting unmuted. So imagine, I'm a skeptic. I'm always sitting in the back of the room. The teacher is presenting stuff, and I'm thinking, why do I need to know this? So I'm going to be that smart alecky student in the back saying, I don't understand. If you have the real data, why do you need a model of it? Why do you need that red curve? Why can't you just use the actual mother's ages?
Well, we can, but remember the mother's ages are based off of, well, in this case, it's based off the CDC data, which is probably mostly not just a sample, but much larger than that. But you have to realize that your samples don't always fit what is going on for the whole population, because your sample is just a snapshot picture of what happens. But also, we don't always get beautifully large data sets like the CDC gives us. And a lot of times we get much smaller data sets. Well, these days we get a lot more bigger data sets, but sometimes we're still working with smaller data sets that we can't possibly look at and get this information from them, get proportions from them, because the data set's too small.
I see.
So that's another reason we look at them theoretical. And then a lot of people like the normal curve, and you'll see it used in a lot of different places. I know you sitting in the back of the room probably don't have kids, but if you ever do have kids, I know that I know that when my son was being tested for different things, I was told, well, you have to be in the upper 3.5% on the normal curve or something like that to get into these courses and so forth. So, or if he's below this percentage on the normal curve, then they might have an issue with like ADHD or something. So you have to understand, because a lot of people use these things out in the world besides in a statistics class. So does that answer your question?
So one thing you're saying is that if we don't have a lot of data, then the normal curve gives us a stand-in for what we might get.
Yes, exactly.
Lots of data. It's an estimate of it.
Right.
And I think the other thing is that the normal curve comes ready prepared with answers to questions like what's big, what's small, what's rare, what's
right. And that's what it is really, is the rareness is important when they're testing kids for whether or not they're going to be in a going to gifted classes. They're looking for the kids that are well gifted, and they're looking for those rare kids. When they're looking for kids that do have ADHD, they're looking for those kids that are considered to have rare behaviors. When they diagnose a lot of different things with different kind of syndromes, they're looking for what is unusual and what they consider unusual. So that is true. Unusualness is a very important thing. And the normal curve gives us that kind of standard of what a unusualness is and what rare considered. I like unusual. I usually deal with if it's less than 5%, it's considered unusual. So if you're in those, if I go back real quickly to the normal curve here, the StatPREP thing we were in, then you can look at what's unusual, and usually it's about 5% is what we consider unusual, because it's down here in this lower range down here. This one and this one together gives you about 5%. So it gives you kind of an idea of what we consider to be unusual, and it's a nice way of measuring that unusualness. Are there any other questions? Doesn't feel like there's any questions going on. I really like this. My students have actually used this one several semesters in a row. I haven't used it this semester yet because we're just not to the normal curve yet. We're still in probabilities right now in my class. But I like it because it really gives the students a visualization of a data set that actually does follow the normal curve, and then we can talk about this theoretical model that we can work with. And then also if you go to use the idea of like the bootstrapping methods or the randomization methods, you can still get this idea of unusualness from those distributions and talk about, you know, it's really unusual if you only have 1% of the population who does something. And I get a lot of students who actually answer that question of what they consider to be unusual from this discussion in class. And my students like it.
We have
and
a
I have to say the picture is much better drawing than I am, because I certainly can't draw a normal curve very well.
Kate, we have a question. How long do you spend with your students on this activity or applet during class?
I probably spend close to an hour with my students on this in class, because I'm letting them pick and choose what's going on, and we're having a long discussion with it. And then when we finish with this little applet or class lesson, I then go on to showing them how to calculate the information on R. And my students are very versed in R, so they're doing well with that, because we've been using it since day one. But this gives them a chance to kind of play around a little bit more with it. So about an hour is what I give. I don't know, this is going to be interesting this year because we lost a day for snow. So we'll see what happens when I go back to school on Tuesday of how far I get. So I might have to shorten it a little bit. It kind of played around a little bit with what I do. Are there more questions?
Okay, and then another one. What do you need to use this app? Is it just the link, or do you need some other software?
So this is all based on a web browser. So as long as you've got Google Chrome or whatever browser you're using, you can use that in class. And then I just give them the link. So I actually copied that link on the What's Normal, on the very first page of the What's Normal, and I posted in my Canvas shell. So, because we use Canvas at my school, and then my students are able to go into that and click on that link directly out of my Canvas shell. So that's kind of how I do that. And then it's just a web browser. So they don't need anything. We're not using any kind of software for this in any fashion, because the software is built into it. You're seeing kind of the background of it. I should make the comment that on occasion, I've had it where the system gets overflowed with too many of my students on it at one time. So sometimes I tell my students they have to work with pairs, or I just tell them, because it'll tell them something like they got disconnected, just tell them to reload it, and then they just have to kind of start from the scratch. But that's kind of the only thing that kind of happens in my class.
We had one more question. How do you incorporate into exams or do you use for learning only?
So I'm using this for learning only, and then my exams would be asking actually normal calculations for the normal curve. I'm actually going to be looking for a data set that I can actually use, that I could ask similar questions like this. I have to admit, I give take-home tests in my class because I can, and my students kind of like that. Not because they're cheating, but because it gives them a chance to really play with the R calculations they have to do without having to do them in class and worry about remembering how to do things on R. But what I do is I give them these lessons, and I could give them the data set and have a new data set and have them kind of answer these same questions, have them plot the data set in R and kind of look at for these proportions and how to calculate these proportions, and then compare it with the normal curve. I'm thinking about doing that this time. I just have to start looking for the data sets that I could actually use it with.
William made a comment. We just did an R exercise yesterday using resampling multiple times, and the students are still struggling with R.
So it depends on how much. My students have actually been using R since my first day I was teaching the class. I missed the first week of class, but I came back the second week. And they actually tell me when I do something wrong in R, and they actually tell me how to do, they ask questions of how to do things. I do a lot of group work in my class, so they're actually hands-on playing with the R material in class, which actually helps a bit. I have some videos that I've created that will show them how to find things in R. We actually do in the StatPREP have a resampling tutorial that will show your students how to also do the materials in R that might be helpful for your students if they want to learn a little bit more about how to do that. If you go into the StatPREP website, under resources, under tutorials, there's a tutorial here on resampling. And if I go into that one, and I've actually used this in my class also. It's a little slow. So this takes a little bit more time because sometimes things are a little bit slow. And then it gives them an idea of what's happening, and it actually shows them, in this case, these tutorials actually show the commands in R. So it helps them to learn it. But I think it helps because I do a lot of hands-on material in my class, and they're able to play around with it more because of that hands-on material. Does that answer or give you some ideas of what you can do? And I can share with you the things I do. I haven't done group work on them actually doing resampling like this, but they're pretty comfortable with R. I mean, some of them are not. Some of them are very comfortable with it. And like I gave a group work one day, we'd done work on creating graphs in R. And then the next group work I did was doing descriptive statistics in R. And a lot of my students were creating graphs for this new data set. So even though we weren't using graphs in that activity that day, they were creating the graphs. So my students have actually gotten pretty comfortable with the R material of what's happening. But I think that also helps for them to understand what's going on. But this tutorial might help to kind of give them some guidelines on how to do resampling. Anything else?
William commented the problem involved computing the odds of two people having the same birthday in a class of 30.
Okay. And then he does resampling with that in his class?
William, can you confirm that?
Because I'm not really sure what you're doing with that, but Danny, maybe you can chime in with more on how he might be able to do that.
Well, so I don't know how exactly William was teaching this lesson, and what was the R that the students were struggling with. But collect class data, only 20 students showed up. Well, that's not quite. But if the idea was to, simulate drawing random 30 from people with birthdays from day 1 to day 365, that can actually be, and finding out how many classes have 2 people with the same birthday, that can be a very concise operation in R. And so it's really another question, but I can show you, if you're interested, I can show you how to do that. But maybe, well, I'll think about, maybe that would be a nice post on the StatPREP blog.
Yes. And so maybe you can email us questions on that separately from this, and then we can maybe help you and see exactly what you were trying to do.
Yeah, well, if you contact me, I'd be really interested to see what you did.
Yeah, that actually brings up an idea of mine as to where you could actually, I collect a survey for my students in the first day of the semester, and I don't ask their birthday, but you could ask the birthday and have that data collected already, and then do resampling from that data you collected already. You may be able to try something like that. Be interesting. The resampling I do in class is one that is on our StatPREP of sorting, and it talks about the heights of Englishmen and English people and heights of French people. And I believe it was a Fisher problem. And so I bring that one into my class and have them do that one. Are there any other questions? All right.
Nothing else has come through at this time.
All right. Well, we'd like to thank you for participating. We'd like to thank the MAA for monitoring this webinar. And we'd like to thank the NSF for funding StatPREP. Please do the survey, which is the link below. It also just been put in the chat room because we really appreciate getting information on this. And if you have any other questions, you're more than welcome to email either Danny or I or anybody else in the StatPREP leadership team, and we can try to answer those questions for you. This recording, as soon as I have it on YouTube, I will post it on our StatPREP website under the webinars. So this one will be showing up in the next few days. Well, probably next week. I'm seeing some other comments in the chat room.
People thanking us and summarizing what they're doing.
Okay, wonderful. Well, thank you. And if anybody else has anything they would like to share what they're trying to do, that'd be wonderful. Like I said, my students do use R from day 1, and they're pretty comfortable with it. The students who aren't comfortable with it probably are the ones who don't do much in class, don't actually participate much in class. And they're also ones that probably would have same problems with other technology like graphing calculators, because they can't figure out how to do simple things on the computers. So it's not that R is the problem, it's more the technology is the problem. So I will thank you, everyone. We appreciate you being here. I know for you it's not a snowy day, but for me it's a nice snowy day. And you all have a wonderful rest of the week or weekend.
Weekend. We'll start with that part of the week.
Yes, let's start with the weekend.
Thank you.
Thank you.